Hello students, I welcome you all to our 6th lecture on electrochemistry. Today's class is mainly for the students of B.Sc semester 5. In our previous class, we have discussed the classification of galvanic cells. We have seen that galvanic cells are of two types. One is concentration cell and another one is chemical cell. Again, concentration cells are of two types, electrode concentration cell and electrolyte concentration cell. Similarly, chemical cells are also of two types, that is with transference and without transference. Now, when we come to electrolyte concentration cells, here again we have another classification, that is with transference and without transference. When we come to with transference, we have again two types, that is transport number of cation is greater than transport number of anion, whereas another category is transport number of anion is greater than the transport number of cation. Now, when we come to without transference, here again we have two categories. What are those? Without transference, which means LJP eliminated by salt bridge or LJP eliminated by chemical cells. So like this, we have classification of galvanic cell. In our previous class, we have already discussed the electrode concentration cells, and in case of electrolyte concentration cells, we have seen the electrolyte concentration cells without transference, in which LJP is eliminated by salt bridge. When we come to LJP eliminated by salt bridge, we have seen that there are again two types in this category. There are again two types in LJP eliminated by salt bridge. What are those? When LJP eliminated by salt bridge, here we have two types, that is electrodes reversible with respect to cations, reversible with respect to cations, whereas another category is the electrodes are reversible with respect to anions. So in our previous class, we have already discussed the reversible with respect to cations, that is electrodes reversible with respect to cations. Thus, we have discussed the electrolyte concentration cell, in which the LJP is eliminated by salt bridge, in which the electrodes are reversible with respect to cations. Now, in our today's class, we will see the electrolyte concentration cells without transference, in which the LJP is eliminated by salt bridge and the electrodes are reversible with respect to anions. Here we have taken the category in which the electrodes are reversible with respect to anions. For this, as usual, in the first step, we write the cell notation. So here the cell notation is like this. Here we are taking silver chloride. This is an electrode. So silver chloride is the electrode and electrolyte is HCl solution. So this is the cell on left hand side. So this is the left hand side half cell, in which silver chloride electrode is dipped in HCl solution, whose activity is A plus or minus 1, which means this is the mean ionic activity. On right hand side, we have taken again silver chloride electrode dipped in HCl solution. Here the solution's activity is A plus or minus 2. So here again we have taken the mean ionic activity. Thus we have left side anode and on right hand side we have cathode. Now if you see here we are using salt bridge, which means the liquid junction potential is removed by using salt bridge. Now if you see the electrodes, here these electrodes are reversible with respect to क्लोराइड आयन। यहाँ इलेक्ट्रोड जो है वो क्लोराइड आयन का हिसाब से वो रिवर्सिबल होगा, इसीलिए these are the electrodes which are reversible with respect to anions. So now in second step we see the electrodic reactions. The electrodic reactions we have at anode oxidation, whereas at cathode reduction. Now when we come to anode, at anode we have oxidation. So in oxidation what does happen? Silver react with chloride ion. So this is the chloride ion of HCl solution on left hand side half cell. So यहाँ पर chloride ion जो है ये left hand side half cell का, so this is silver chloride, ये आपका silver chloride ball जैसा है. Again here also we have silver chloride electrode. So silver and silver chloride both are solids and both are mixed together, and these two half cells are connected by a salt bridge. यहाँ ये U shaped tube जो है एक salt bridge है, and we have HCl solution on both sides. But here left hand side HCl solution's activity is A plus or minus 1, whereas right hand side activity is A plus or minus 2. And these two electrodes are connected by an electric wire. Like this. So now on left hand side silver is reacting with chloride ion. So here HCl solution we have on left hand side half cell. So with that chloride ion, silver reacts to form silver chloride and 1 mole of electrons will be evolved. So these 1 mole of electrons, they travel through the electric wire and they react with silver chloride on right hand side cell, so that it forms silver and chloride ions on right hand side half cell. Thus at anode oxidation is happening, whereas at cathode reduction is happening. If you see the overall reaction, silver and silver cancel, silver chloride cancel, 1 electron, 1 mole of electron, 1 mole of electron cancel. So remaining we have chloride ions on left hand side to form chloride ions on right hand side. So इन दोनों के बीच में हमें equilibrium होगा, which means chloride ions are traveling from left hand side to right hand side. Chloride ions are moving from left hand side half cell to right hand side half cell. In actual, these ions are not moving through salt bridge, but the overall picture looks so. ये overall picture हम देखेंगे तो हमें ऐसे दिखेगा कि chloride ions left hand side से right hand side move हो रहा है. This is because the change in concentration at the electrode and electrolyte interface. If you see on left hand side, chloride ion is reacting with silver, so that the concentration of chloride ion is decreasing on left hand side, and come to right hand side, more and more silver chloride is being reduced to silver and thus produce chloride ions on right hand side. Thus on right hand side chloride ion concentration is increasing and on left hand side chloride ion concentration is decreasing. यहाँ पर हम लेफ्ट हैंड साइड देखेंगे तो सिल्वर जो है वो क्लोराइड आयन से रिएक्ट होके सिल्वर क्लोराइड हमें बना रहा है. That is why the concentration of chloride ions on left hand side decreases, whereas when we come to right hand side, silver chloride is being reduced to form silver and chloride ions. So these chloride ions, they increase the concentration of chloride ions on right hand side. Thus the overall picture looks like the chloride ions are moving from left hand side to right hand side. It happens when we take more concentration of HCl on left hand side, which means the mean ionic activity of HCl on left hand side, that is A plus or minus 1, is greater than the mean ionic activity of HCl on right hand side. Thus, the flow of chloride ions is from anode to cathode. That is from higher concentration to lower concentration, which shows the mean ionic activity of HCl on left hand side is greater than the mean ionic activity of HCl on right hand side. Thus, we have seen two steps. What are those? First one is cell notation and second one is electrodic reactions. Now, what is the third step? In third step, we see cell potential. So, the third step is cell potential. So, in cell potential, we have E cell is equal to E2 minus E1, which means reduction potential of cathode minus reduction potential of anode. We have seen many times that why we have negative symbol here. Why do we have negative symbol here? Because on left hand side oxidation is happening, but we are expressing the potential in terms of reductions. That is, here we are writing the reduction potential for anodic half cell 2. That is why here we are using negative symbol. So which means here both we are writing in terms of reduction potentials. Thus, reactions when we write, we have to take both in terms of reductions. So what will be the reactions? We have AgCl react with electron to form Ag plus chloride. This is the reaction which is happening on right hand side half cell. So here reduction is happening, so no problem. But when we come to left hand side oxidation is happening, but we are writing in terms of reductions, so we have to take reduction reaction. That is why here we have AgCl react with electron to form Ag plus chloride ion on left hand side. So यहाँ पर chloride ion left hand side का हमने ले लिया है. Now what will be the fourth step? In fourth step, by using Nast equation, we write E cell. So thus E cell is equal to right hand side reduction potential minus left hand side reduction potential. So if you see, according to Nast equation, E cell is equal to E naught cell minus RT by NF ln concentration of products minus concentration of reactants. When we apply Nast equation to half cell, we get like this. So here the standard reduction potential is E naught AgCl to Cl minus. Here in actual what is happening? Silver chloride, which means E naught Ag plus is being reduced to Ag. Ag plus जो है Ag जैसे reduce हो रहा है. So this is being represented like AgCl. Instead of Ag plus we are writing AgCl, and it is giving chloride ion also. Here chloride ion is actively participating in the reaction. That is why here we are showing chloride ion. Thus E cell is equal to E naught AgCl to Cl minus minus RT by N. N माने how many electrons here? 1 mole of electrons. Thus N is equal to 1. That is why minus RT by 1F ln concentration of products or activities of products. What are the products? Silver and chloride ion on right hand side. So activity of silver into activity of chloride ion on right hand side divided by activity of AgCl minus again for this standard reduction potential E naught AgCl to Cl minus minus RT by 1 of ln activity of products. What are the products? Silver and chloride ion on left hand side. Thus ln activity of silver into activity of chloride ion on left hand side divided by AgCl. The activities of solids are 1. Thus, activity of silver is 1 and activity of AgCl is 1. So, these will be cancelled. Thus, what do we get? And E naught AgCl to Cl minus and E naught AgCl to Cl minus both will be cancelled because there is minus here. So, what is left? E cell is equal to minus RT by F into Ln activity of chloride ion on right hand side minus in bracket again minus RT by F Ln activity of chloride ion on left hand side. So here minus into minus plus and RT by F common. So what is left? That implies RT by F Ln यहाँ एक्टिविटी ऑफ क्लोराइड आयन लेफ्ट हैंड साइड इसका पॉजिटिव सिंबल होगा क्योंकि माइनस इंटू माइनस प्लस है. Thus Ln activity of chloride ion on left hand side will come to numerator chloride ion on left hand side divided by activity of chloride ion on right hand side. So this is the formula for E cell. Thus we get E cell is equal to RT by F Ln activity of chloride ion on left hand side divided by activity of chloride ion on right hand side. Now when we take activity of HCl, how can we write? This is equal to activity of H plus ion into activity of chloride ion. Now what is mean ionic activity? Mean ionic activity is equal to A plus or minus is equal to square root of activity of H plus into activity of Cl minus. If we assume activity of H plus ion and activity of chloride ion both are equal, then what will happen? That implies activity, mean ionic activity A plus or minus is equal to activity of chloride ion whole square and square root. Square root and square cancel, which means instead of mean ionic activity we can write activity of chloride ion, which means we can write instead of activity of chloride ion on left hand side we can write mean ionic activity, that is A plus or minus 1 divided by A plus or minus 2. Thus E cell is equal to RT by F Ln mean ionic activity 1 divided by mean ionic activity 2. So E cell will be positive when the numerator is greater than denominator, which means A plus or minus 1 should be greater than A plus or minus 2. Then only E cell will be positive. Thus we can discuss about electrolyte concentration cells without transference, in which the LJP is eliminated by salt bridge and the electrodes are reversible with respect to anions. Here, how the electrodes are reversible with respect to anions? If you take oxidation reaction of this one, here if we increase chloride ion concentration, more and more reaction will happen, which means forward reaction will take place. But when we decrease the chloride ion concentration, what will happen? Reverse reaction takes place, which means reduction will happen. Thus this reaction is reversible with respect to chloride ion. यहाँ पर ये रिएक्शन जो है क्लोराइड आयन के हिसाब से रिवर्सिबल है. अगर एनोडिक हाफ सेल ले लेंगे, अगर क्लोराइड आयन का कंसंट्रेशन और बढ़ाएंगे तो हमें ऑक्सीडेशन और फेवरेबल होगा. लेकिन अगर हमने क्लोराइड आयन का कॉन्सेंट्रेशन घटाएंगे तो रिडक्शन फेवरेबल होगा। इसका मतलब हमें ये वाला रिएक्शन जो है क्लोराइड आयन के हिसाब से रिवर्सिबल हो रहा है। Now let us discuss the electrolyte concentration cells in which LJP is eliminated by using chemical cells. Here LJP is eliminated by chemical cells, which means we can construct the concentration cells by using chemical cells. By using chemical cells without transference. यहाँ पर chemical cells जिसका transference नहीं है, which means which are having no liquid junction potential, will be connected in opposite direction so that there will be no liquid junction potential in the overall concentration cell. यहाँ पर हम दो chemical cells को ले लेंगे जिसमें कोई भी लिक्विड जंक्शन पोटेंशियल नहीं है और ये दोनों केमिकल सेल्स को ऑपोजिट डायरेक्शन में हम कनेक्ट करेंगे ताकि कोई ओवरऑल लिक्विड जंक्शन पोटेंशियल ना हो। ऐसे हमें एक कॉन्सेंट्रेशन सेल कंस्ट्रक्ट होगा। So thus here we are constructing a concentration cell without transference by using the chemical cells which are without transference connecting in opposite direction. So now again here we have two types. One is the extreme electrodes are reversible with respect to cations, and another one is the extreme electrodes are reversible with respect to anions. The first category we see the extreme electrodes are reversible with respect to cations. So here we take the extreme electrodes reversible with respect to cations. So as usual, first step we have to write cell notation. So here we have two chemical cells. So left hand side we have one chemical cell and right hand side we have another chemical cell. यहाँ left hand side एक chemical cell है और right hand side दूसरा chemical cell है, and left hand side and right hand side both cells are without transference. अगर यहाँ पर हम देखेंगे दोनों electrodes को एक ही solution में dip किया गया है. So what is that solution? HCl solution. तो यहाँ पर HCl solution same solution में हाइड्रोजन इलेक्ट्रोड और सिल्वर एंड सिल्वर क्लोराइड इलेक्ट्रोड ये दोनों के एक ही सॉल्यूशन में डिप किया गया है. Thus it is without liquid junction potential. Same on right hand side. So here also both silver and silver chloride and hydrogen electrode are dipped in HCl solution. But the only difference is the concentration on left hand side HCl solution and the concentration on right hand side HCl solution both are different. As their concentrations are different, the overall cell is a concentration cell. Here these two chemical cells are connected by salt bridge. यहाँ दोनों cells को एक salt bridge से connect किया गया है. Here salt bridge can be represented like this or it can be represented by two vertical lines. If you see the cell, the overall cell will be like this. Here on left hand side, hydrogen electrode is dipped in HCl solution. Whenever we use hydrogen electrode, there should be platinum. So यहाँ पर एक platinum plate है, तो ये और hydrogen gas इस तरफ से हम supply कर रहा है. So here we have hydrogen electrode and on right hand side we have silver and silver chloride. So these two are dipped in same solution, that is HCl solution. यहाँ पर same HCl solution हमें है जिसका एक्टिविटी है मीन आयनिक एक्टिविटी ये प्लस आर माइनस 1. राइट हैंड साइड हम ऑपोजिट डायरेक्शन में हमने ले रहा है. यहाँ लेफ्ट हैंड साइड वाले में एनोडिक हाफ सेल हाइड्रोजन हाफ सेल है. राइट हैंड साइड रिडक्शन हाफ सेल जो है सिल्वर सिल्वर क्लोराइड वाला. लेकिन इस राइट हैंड साइड सेल में ओवरऑल सेल में लेफ्ट हैंड साइड हाफ सेल जो है वो सिल्वर सिल्वर क्लोराइड है और राइट हैंड साइड हाफ सेल है हाइड्रोजन हाफ सेल. एंड दीज टू केमिकल सेल्स आर कनेक्टेड बाय साल्ट ब्रिज. ये दोनों केमिकल सेल्स को एक साल्ट ब्रिज से हम कनेक्ट किया गया है. and as there is difference in concentration of HCl solution, so the overall solution is a concentration cell. Thus, in first step, we have seen the cell notation. In second step, what do we see? Electrodic reactions. In second step, we see electrodic reactions. If you take the left hand side cell, so here this is the left hand side cell. So in left hand side cell, again we have anode and cathode. So at anode we have hydrogen electrode, and at cathode we have silver and silver chloride electrode. So at anode, if you see, oxidation takes place. Thus H2 is being oxidized to H plus ion and to produce 1 mole of electrons. Here the concentration of H plus ion is represented by H plus left hand side, which means left hand side cell. Left hand side cathode, if you see, at cathode reduction takes place. Thus Ag plus Cl minus AgCl is being reduced to Ag and produce chloride ion. So this is left hand side cell. That is why we are writing Cl minus on left hand side. Similarly, on right hand side, if you take on right hand side, the anodic half cell is silver and silver chloride half cell. Thus here oxidation takes place, which means silver react with chloride ion on right hand side cell, so that it forms AgCl and 1 mole of electrons. These 1 mole of electrons will be taken by H plus solution on right hand side cell to produce H2 gas. So thus in overall, what is in common? AgCl will be cancelled, Ag will be cancelled, H2 and H2 will be cancelled, and the remaining we have H plus on right hand side plus chloride on right hand side to produce H plus on left hand side and Cl minus on left hand side, which means it looks like HCl from right hand side moves to HCl on left hand side. यहाँ पर HCl solution right hand side से left hand side का तरफ मूव हो रहा है. इसका मतलब हमें किस तरफ concentration ज्यादा होना है? Right hand side. Thus we have seen two steps. First step we have seen cell notation. Second step we have seen electrodic reactions. Now third step. What is the third step? In third step we say E cell. So what is E cell here? We have connected two cells in series. यहाँ पर हम दो cells को series में connect किया गया है. तो इसका मतलब left hand side cell, E cell of left hand side cell plus E cell of right hand side cell. ये दोनों को ऐड करेंगे तो हमें ओवरऑल सेल पोटेंशियल हमें आएगा. Thus E cell is equal to E cell on left hand side cell plus E cell on right hand side. यहाँ प्लस क्यों ले रहा है? Because both are connected in series. यहाँ दोनों को एक सीरीज में हमने कनेक्ट किया गया है. Now E cell on left hand side, how to write? Here E cell on left hand side, again we are having anode and cathode, which means E2 minus E1. ये कौन सा सेल है? ये left hand side cell plus again E2 minus E1. ये कौन सा सेल है? ये right hand side cell. तो दोनों तरफ हम E2 E1 लिख रहा है, तो डिफरेंस समझने के लिए E2 dash and E1 dash या E2 prime minus E1 prime on right hand side हम लिख सकते हैं. Thus we have got E cell is equal to E2 minus E1 on left hand side plus E2 prime minus E1 prime on right hand side. So now again we will write the reactions all in terms of reduction reactions, because here we are taking all reduction potentials. यहाँ पर हम सारे reduction potentials हम ले रहा है, इसीलिए जैसे हम फोर्थ स्टेप में लिख रहा था, सारे reactions को reduction reactions में हम represent करेंगे. Thus, we can have all the four reactions. So here in blue color we have written left hand side cell, and here in brown color we have written right hand side cell. Now when we come to left hand side cells, on right hand side reduction is happening. So what is that reduction? AgCl is being reduced to Ag and produce chloride ion on left hand side cell, and hydrogen in actuality is being oxidized, but the reaction is being written in terms of reductions. That is why H plus on left hand side to produce half H2. इसीलिए हमें यहाँ पर नेगेटिव सिंबल यूज कर रहा है. So here negative symbol is being used because here in actual oxidation is happening, but we are taking reduction potentials. Similarly, when we take in right hand side cell, extreme right we have reduction, and in right hand side cell left electrode we have oxidation, but we are taking reduction potentials. That is why here we are writing reduction reaction. Thus here two places we have got negative. Why we have got negative? Because in actual oxidation is happening, but we are writing in terms of reductions. Thus by using Nast equation we get E cell like this. यहाँ पर एक एक हाफ सेल को हम नास्ट इक्वेशन अप्लाई करेंगे. क्या है नास्ट इक्वेशन? E cell is equal to E naught cell minus RT by NF ln activity of products minus activity of reactants. तो ऐसे हम नास्ट इक्वेशन को अप्लाई करेंगे तो हमें E cell क्या आएगा? E cell is equal to E naught. यहाँ हाफ सेल कौन सा है? यहाँ पर देखेंगे रिएक्शन क्या है? AgCl to form Ag and Cl minus on left hand side. तो यहाँ पर हम स्टैंडर्ड सेल पोटेंशियल या स्टैंडर्ड हाफ सेल पोटेंशियल हम लिख सकते हैं. तो AgCl to क्लोराइड आयन लिख सकते हैं माइनस RT by how many moles? 1 mole of electrons. So 1F into ln products क्या है? सिल्वर एंड क्लोराइड आयन ऑन लेफ्ट हैंड साइड, एंड रिएक्टेंस क्या है? AgCl. तो यहाँ पर हमें एक्टिविटी ऑफ Ag into activity of chloride ion on left hand side cell divided by activity of AgCl. तो यहाँ पर पहला रिएक्शन का हो गया. Now come to second one. Here reduction we have written, but in actual what is happening? Oxidation. That is why we should take minus. So minus, यहाँ overall हम bracket में रख देंगे. So minus, So here what is the standard half cell? Hydrogen electrode. That is why E naught H plus to H2 minus RT by how many moles? 1 mole. 1F into ln, यहाँ पर प्रोडक्ट्स क्या है? हाफ H2. इसका मतलब एक्टिविटी ऑफ H2 गैस पावर 1/2 डिवाइडेड बाय रिएक्टेंस क्या है? H plus ion on left hand side. Activity of H plus ion on left hand side. ऐसे हम ओवरऑल लेफ्ट हैंड साइड सेल को लिख सकता है. नाउ कम टू राइट हैंड साइड सेल. सो राइट हैंड साइड सेल में हमें पहले रिडक्शन क्या है? H प्लस राइट हैंड साइड टू हाफ H2. यही तो रिडक्शन हो रहा है. तो ओवरऑल हम प्लस ले लेंगे. तो प्लस ब्रैकेट ओपन E नॉट. यहाँ स्टैंडर्ड हाफ सेल क्या है? हाइड्रोजन इलेक्ट्रोड का है. तो इसका मतलब H plus to H2 minus RT by F, यहाँ 1F into ln प्रोडक्ट्स क्या है? एक्टिविटी ऑफ H2 पावर 1/2 divided by activity of H plus on right hand side. माइनस क्यों? लास्ट ये रिएक्शन जो है ऑक्सीडेशन हो रहा था, लेकिन हमने रिडक्शन टर्म्स में लिख रहा है, इसीलिए माइनस। तो माइनस तो इसके लिए स्टैंडर्ड हाफ सेल पोटेंशियल क्या है? ई नॉट ए जी सी एल टू सी एल माइनस आर टी बाय एफ और 1f एल एन। व्हाट आर द प्रोडक्ट्स? या प्रोडक्ट्स क्या है? एक्टिविटी ऑफ Ag into activity of chloride ion on right hand side divided by activity of AgCl. Now जहां जहां एक्टिविटी ऑफ Ag, एक्टिविटी ऑफ AgCl और एक्टिविटी ऑफ हाइड्रोजन है, वहां 1 हम लिख सकता है, क्योंकि हाइड्रोजन का भी 1 एटमॉस्फेयर है तो 1 लिख सकता है, और सॉलिड्स की एक्टिविटी भी 1 है, तो हमें ओवरऑल ई सेल क्या होगा? तो ई सेल इज इक्वल टू हाँ क्या है? ई नॉट AgCl टू Cl माइनस RT बाई F Ln। यहाँ पर क्या बचा है? यहाँ एक्टिविटी ऑफ सिल्वर 1 लिख सकता है और एक्टिविटी ऑफ AgCl भी 1 लिख सकता है। बचा क्या है? Ln एक्टिविटी ऑफ क्लोराइड आयन ऑन लेफ्ट हैंड साइड माइनस E नॉट H प्लस टू H2 माइनस RT बाई F Ln एक्टिविटी ऑफ हाइड्रोजन 1 लिख सकता है, तो 1 पावर 1 बाई 2 1 है, तो बचा क्या है? 1 डिवाइडेड बाय एक्टिविटी ऑफ H प्लस ऑन लेफ्ट हैंड साइड। यहाँ ब्रैकेट इसीलिए लिखा कि ब्रैकेट का बाहर माइनस है, प्लस ओवरऑल प्लस अब बचा क्या है? E नॉट H प्लस टू H2 E नॉट H प्लस टू H2 माइनस RT बाई F Ln। यहाँ एक्टिविटी ऑफ हाइड्रोजन 1 हो जाएगा, अब बचा क्या है? 1 डिवाइडेड बाय एक्टिविटी ऑफ H प्लस ऑन राइट हैंड साइड माइनस इन ब्रैकेट E नॉट AgCl टू क्लोराइड आयन माइनस RT बाई F। यहाँ क्या है? एक्टिविटी ऑफ Ag 1 है, एक्टिविटी ऑफ AgCl भी 1 है, तो बचा Ln एक्टिविटी ऑफ क्लोराइड आयन ऑन राइट हैंड साइड। हियर E नॉट AgCl टू क्लोराइड प्लस है, लेकिन यहाँ पर माइनस है, कैंसिल। अगेन E नॉट H प्लस टू H2, यहाँ माइनस है और यहाँ प्लस है, कैंसिल। तो बचा क्या है हमें? दैट इम्प्लाइज RT बाई F सब में कॉमन है, उसको बाहर ले आइए, तो RT बाई F सब में कॉमन है, RT बाई F इंटू, अब पहले यहाँ माइनस है तो माइनस Ln एक्टिविटी ऑफ क्लोराइड आयन ऑन लेफ्ट हैंड साइड माइनस Ln एक्टिविटी ऑफ क्लोराइड आयन ऑन लेफ्ट हैंड साइड। यहाँ माइनस इंटू माइनस प्लस, तो इसका मतलब प्लस ln 1 by activity of H plus ion on left hand side. Now come to here. यहाँ पर हमें माइनस ऑलरेडी है और RT by of कॉमन, तो बचा क्या है माइनस ln 1 by activity of H plus ion on right hand side. यहाँ माइनस इंटू माइनस प्लस, तो RT by of कॉमन गया तो प्लस ln activity of chloride ion on right hand side. ऐसे हमें यहां पर हम देखेंगे यहां माइनस है, इसका मतलब ये भी डिनोमिनेटर में जाएगा और ये माइनस इस तरफ ले जाएंगे, ये एक्टिविटी ऑफ H प्लस आयन ऑन राइट हैंड साइड न्यूमरेटर में आएगा। इसका मतलब हमें राइट हैंड साइड के एक्टिविटीज जो है न्यूमरेटर में आ रहा है और लेफ्ट हैंड साइड के एक्टिविटीज जो है डिनोमिनेटर में आ रहा है। Thus, E cell is equal to RT by F ln activity of H plus ion right hand side into activity of chloride ion on right hand side divided by activity of H plus ion on left hand side into activity of chloride ion on left hand side. Now, as we have already seen, activity of HCl is equal to activity of H plus ion into activity of क्लोराइड आयन। तो इसका मतलब एक्टिविटी ऑफ H प्लस आयन इंटू एक्टिविटी ऑफ क्लोराइड आयन का जगह एक्टिविटी ऑफ HCl लिख सकते हैं हम ऐसे। सो वी हैव E cell is equal to RT by F ln activity of HCl on right hand side divided by activity of HCl on left hand side। तो ये E cell हमें पॉजिटिव होना है, इसका मतलब किस तरफ कंसंट्रेशन या एक्टिविटी ज्यादा होना है राइट हैंड साइड, बिकॉज ये न्यूमरेटर ज्यादा होना है डिनोमिनेटर से, तभी हमें E cell पॉजिटिव होगा। Thus, activity of HCl on right hand side should be greater than activity of HCl on left hand side. Now, इसको हम मीन आयनिक एक्टिविटी का टर्म्स में लिखना चाह रहा है। What is the relation we have? Mean ionic activity A plus or minus is equal to square root of activity of H plus ion into activity of Cl minus ion। अगर हमने H plus ion और Cl minus ion की एक्टिविटीज सेम हम ले लेंगे तो क्या होगा ये, तो स्क्वायर रूट ऑफ एक्टिविटी ऑफ H plus ion होल स्क्वायर, क्योंकि हमने H प्लस का क्लोराइड का दोनों का सेम हमने मान लिया, तो इसका मतलब दैट इज इक्वल टू एक्टिविटी ऑफ H प्लस आयन। इसका मतलब मीन आयनिक एक्टिविटी, दैट इंप्लाइज मीन आयनिक एक्टिविटी इज इक्वल टू एक्टिविटी ऑफ H प्लस आयन, लेकिन ये क्लोराइड आयन का भी बराबर है, तो विच इज इक्वल टू एक्टिविटी ऑफ क्लोराइड आयन। बट what is the activity of HCl? Activity of HCl क्या है, activity of H plus ion into activity of chloride ion। तो ये दोनों के जगह मीन आयन की एक्टिविटी लिख सकते हैं। That implies E cell is equal to RT by F ln मीन आयनिक एक्टिविटी राइट हैंड साइड सेल का हमने 2 मान लिया था इनटू अगेन मीन आयनिक एक्टिविटी 2 divided by मीन आयनिक एक्टिविटी लेफ्ट हैंड साइड मीन आयनिक एक्टिविटी हमने 1 माना था, मीन आयनिक एक्टिविटी 1, तो ये स्क्वायर आएगा, स्क्वायर को न्यूमरेटर में ले जाएंगे तो ये स्क्वायर आएगा। दैट इंप्लाइज E cell is equal to RT by F ln mean ionic activity 2 divided by mean ionic activity 1 whole square। होल स्क्वायर, तो ये स्क्वायर जो है ln का सामने आ जाएगा, तो हमें क्या आएगा, दैट इंप्लाइज वी गेट E cell is equal to 2 RT by F ln mean ionic activity 2 divided by mean ionic activity 1. ऐसे हम electrolyte concentration cells without transference in which LJP is eliminated by chemical cells और उसमें ही the extreme electrodes reversible with respect to cations वाला example हम देख सकता है. So here how the extreme electrodes are reversible with respect to cations. So if you see here, what are the extreme electrodes? Hydrogen and hydrogen. So hydrogen electrodes are the extreme electrodes, which means what is the reaction here? यहाँ पर अगर left hand side हम देखेंगे तो यहाँ पर reaction क्या हो रहा है? Oxidation. इसका मतलब half H2 to form H plus left hand side concentration into electron. अगर यहाँ पर हमने H प्लस का कॉन्सेंट्रेशन घटाएंगे, डिक्रीज करेंगे तो और ऑक्सीडेशन होगा. इस बार HCl का कॉन्सेंट्रेशन बढ़ाएंगे, इसका मतलब H प्लस कॉन्सेंट्रेशन लेफ्ट हैंड साइड सेल में बढ़ाएंगे तो क्या होगा? ऑपोजिट रिएक्शन, इसका मतलब रिडक्शन होगा. इसका मतलब सेम H प्लस आयन से ये वाला रिएक्शन जो है रिवर्स हो रहा है. नाउ कम टू राइट हैंड साइड. राइट हैंड साइड में खुद ही रिएक्शन क्या हो रहा है? रिडक्शन. इसका मतलब H plus on right hand side is reacting with electron to form half H2. यहाँ पर हमने अगर H plus आयन का concentration right hand side cell में हमने बढ़ाएंगे तो क्या होगा? और ज्यादा रिडक्शन यहाँ पर होगा. लेकिन इस बार हम क्या करेंगे? H plus आयन concentration right hand side cell में डिक्रीज करेंगे तो क्या होगा? ऑपोजिट रिएक्शन. इसका मतलब ऑक्सीडेशन होगा. इसका मतलब हमें दोनों एक्सट्रीम इलेक्ट्रोड जो है सेम आयन, इसका मतलब H प्लस आयन से रिवर्सिबल हो रहा है. दैट इज व्हाई दीज आर द इलेक्ट्रोड्स व्हिच आर रिवर्सिबल विथ रेस्पेक्ट टू कैटायंस. ऐसे हम LJP एलिमिनेटेड बाय केमिकल सेल्स का एक एग्जांपल हम देख सकते हैं. नाउ व्हाट विल बी द सेकंड एग्जांपल? In the second example, we will have extreme electrodes reversible with respect to anions. So that we will see in our next class. So with this, I am concluding today's lecture, and in our next class, we will see the liquid junction potential eliminated by chemical cells in which the extreme electrodes are reversible with respect to anions. And also, we will see how to deduce liquid junction potential in a concentration cell in our next class. Thank you.